Hello and welcome to Morehouse's Math Menagerie. Today we're going to talk about confidence levels. Here on this graph we have a population that is indicated by this gray normal distribution here. The red curve represents the sampling distribution of samples from this population of size 25. Now we're going to take a sample and create a 95% confidence interval from that sample. So here we go. You'll notice that this green line here represents the parameter of the population that we're trying to estimate. And we have our confidence interval here. The middle dot here is our point estimate or our statistic. And each of these lines to the left and the right of it are the margin of error. The yellow dots below are the actual sample from the population that helped us calculate this confidence interval, but we can ignore those for now. You will note that this confidence interval did in fact capture the true proportion. Let's look at that again. So here we've taken another sample of size 25. We have calculated the point estimate here in the middle and the margin of error to either side for this 95% confidence interval. And again, we've captured the true parameter for the population. Now let's do this a large number of times. So I'm going to take several samples of size 25, and here we have 102 samples that we've taken now. You will note that each of these samples, we created a confidence interval for them, and that the red ones here missed the parameter, while all of the black ones captured the parameter. Out of the 102 total confidence intervals that we've created, 92% of them captured the parameter. Let's do this a bunch more. I'm going to get up here close to 300 samples. Oh, went a little bit over. So we're looking at 327 samples now. Again, the red ones have missed and the black ones have hit the parameter. That's at 94% rate of hitting now. You'll notice that's very close to our confidence level of 95%. Let's see what happens when we take some more. All right, now we're up to 500 samples that we've made, and for each of those, we've created a confidence interval. 94% of them have captured the true parameter, this green line that we're trying to capture, and only 6% of them have missed. Again, you'll notice this percent that have captured the true proportion is very close to our confidence level. If we continued this process and did a very large number of samples, and for each of those samples we created a confidence interval, about 95% of them would capture the true proportion. So a confidence level is the percent of samples for a large number of samples that would capture the true proportion. Now, one thing we talked about in class is that if you want to increase confidence, you can widen your margin of error. I want to show that to you here. If I increase my level of confidence, you'll notice that my confidence intervals are widening. Now you'll notice that at a 99% confidence level, that 99% of the 502 confidence intervals that we've created now capture the true parameter. Now, if I decrease the confidence level, what I'm doing is I am making the confidence intervals narrower. You'll notice down here. If I decrease this all the way to 80% confidence, you'll see that the percent that captured the true parameter is now right at 80%. So again, a confidence level is the percent of confidence intervals for a large number of samples that would capture the parameter we are trying to estimate. Now I want to come over here and look at an example with you guys about how we interpret confidence intervals. So the gym teacher of a large high school wants to estimate the mean number of push-ups students at his school can do in 1 minute. He selects a random sample of 30 students from those who are there after school for sports practice. He records how many push-ups each of the students in the sample can do in 1 minute. He calculates the 90% confidence interval to be 24.1 to 28.5. Now, if we're going to interpret this confidence interval, we're going to say if the gym teacher takes a large number of samples and calculates a confidence interval for each sample, about 90% of them would capture the true mean number of push-ups for students at this school. That's what this confidence interval means. Now, this is just the technical definition. However, on the problems we do, we're going to have an interpretation in context. And we talked about this in class, but I thought it'd be good to reiterate here. After we've constructed a confidence interval and are asked to interpret it in context, we want to say that we are 90% confident that the interval 24.1 to 28.5 captures the mean number of push-ups that students at this school can do in 1 minute. The first interpretation was more of a technical interpretation. The second one is more practical and in context, and most often we will use this second one. Thank you for joining me. Have a great day.